Hi, I'm Mark Wilson, the Engineering Heretic, and today we're going to look at what you see here is a micrometer, and we're going to look at reading micrometers, and we'll look at this in a little bit of detail. What you see there is there's a bunch of measuring instruments there. These are all metric, and I won't be dealing with imperial at all. In Australia we're all metric. I might talk about a few imperial sizes that you can measure with a metric micrometer. We're not going to deal with metric with imperial at all. So let's have a look at a 0 to 25 micrometer. Here we have one here. Now this one here, this is mine from, I bought this in 1976. So that makes it coming up about 48 years old. It's a 0 to 25, and let's just go through how you go about reading this and a couple of things you do to check these particular instruments. Now, as I said before, this is 48 years old. So the first thing you do when you pick up a micrometer is first of all check the function of it, make sure everything's nice and smooth. We have a ratchet up here which we use for tensioning, but oddly enough I very rarely use this. We have the main thimble. We have a thing called the barrel, which is this section here. That's the barrel. This is the thimble. We have the barrel scale, and of course we have the thimble scale as well. Now, the first thing you check with a micrometer is you want to check the zero setting. If you have this is a 25 to 50, you'd need a spacer of 25 mil to check that, but a 0 to 25, we just need a piece of paper. We'll do this. Wind this down on a piece of paper. We want to make sure the jaws are clean, and they're carbide jaws on this particular mic. This is a Michi Toyo. We pull that out there. That ensures the jaws are clean. We'll wind this up here and we'll check the zero. We will use the ratchet here. We'll let that click a couple of times, and you'll see here that there's scale there. It's a bit hard to see. Sometimes there with the camera angle we might see a bit of parallax error, but we'll see here that the zero line of the thimble and the barrel line, which is this one here, that's that zero line there, line up perfectly. There's obviously, you see as this runs around, you'll notice obviously it's running on a thread. The thread is quite a precise thread, and the pitch of the thread inside here, we'll wind that to zero there. We'll wind that around one full turn, and you see this counting off here. It's called a micrometer, but oddly enough, this doesn't read in microns, this particular micrometer. This reads in 100ths or 10 micron intervals, and each one of those divisions is 10 microns. Up to there you'll see 50 microns. That's 100 microns there, but we'll kind of ignore that. We'll call these hundredths because to keep it a little bit simpler. So if I wind this around one full revolution till the zero comes up on that zero line right here, this thimble has moved out a half a millimeter. So this has moved out a half a millimeter. So the pitch of this particular thread is precisely 1/2 of a millimeter. So that will measure a full range of a half a millimeter, just reading straight off the dial. We get past a half mil though. I'll wind this a little bit further. You'll see here that there is, on the other side, there's actually a half mil graduation there. So once we go past the zero for the first time there, we need to add 0.5 to this particular size. So if I go to that particular size there, that will be 0.55 millimeters precisely. So you have to add, that will be 0.6, and so on and so forth until we get all the way up to 1 millimeter exactly. And we've moved this there now 1 full millimeter, and you'll see there's a 1 mil graduation line that you can see there on the edge of the thimble. So now we're back on millimeters again, and this of course will be 1.1 millimeter, and so on and so forth. Now, to check this, like I said before, this particular micrometer is from 1976, and it's still quite serviceable today after nearly 48 years. Now, we would like to check this. I have checked this every 5 millimeters in the past, and it still reads correctly every 5 millimeters. So I put a 5 millimeter slip gauge in there, a 10, and so on and so forth. But we'll wind this all the way out to 25 because I do have a 25 mm slip gauge. And it's always a point to never wind a micrometer past about a millimeter past its range. Now this range here is 0 to 25. It actually says it on the frame itself. It says 0 to 25, and it says there 0.0 or 0.01 millimeters, and that's the smallest graduation that this particular micrometer will work to. So we'll wind this all the way out to 25 and a little bit past that. We'll grab ourselves a slip gauge and we'll just check and make sure this reads off. It's not 25. Drill a little bit more. 25 millimeters. There we go. We'll wind that down there and we'll just check that there. And of course that comes up exactly on 25 millimeters. So after 48 years over that range there, this micrometer is still reading perfectly correct. And I expect that too. I expect for this to last probably another 50 years. Maybe I'll have to give it to my son or something like that, and he can take over when I'm finished with it. Now, I mentioned before there's this thimble at the end here. Most tool makers don't use it. Okay, we'll measure something by just using feel on that particular dial there. And when you measure something, I'll grab something here to measure. Let's say we're going to measure a drill. I don't know what size this drill is, but we'll just put a drill on there. And we'll just measure. Normally you measure a drill across the tip at that point there. We're going to wind this down. And we're going to measure the tip of this. And I'm not using that particular, just across the corners. And I find that drill is a fraction under, just 0.15 under a 7.5. So basically it's a 7.5 mil. It's a fraction under 7.5. It's a 7.5 millimeter drill. What toolmakers normally do is we do a little bit of a test. We hold it with our finger in the thimble and we kind of wiggle it backwards and forwards, taking multiple, just twiddling it backwards and forwards, taking multiple sizes there, trying to find the best size to suit there. And if I just twiddle that around there, I find out that I get that all the way out and it measures exactly 7.5, maybe a fraction under. But I'm not using the thimble at all. I'm just using the barrel, and most tool makers do not use the thimble at all, unless of course they have a good reason. Okay, so that's how you read that particular micrometer there. So if I want to need another size, let's measure another drill here. We'll just measure this one here. I don't know what size this is, but we'll just read off as it comes. We'll just measure right on the tip there. And we'll see here we get it's 10, and it's a one full turn past 10. So that will be 10.5 millimeters, and that's measuring exactly 10.5 millimeters. You can measure the next decimal place to some degree with this micrometer, and most people do. In fact, I have another micrometer I'll talk about in a minute. But this one here, if you divide that scale, using your mind's eye a little bit, divide this scale here up into 10 there. So if you have that halfway there, that will be a 10 point, that one there, well, that would be 10.5 right there. If I had that at that point there, that would be a half a graduation pass. That would be 10.55, okay? And I'm just measuring off the last decimal place by guessing between the 2 points there. And you can quite easily divide this up into tenths along each one of those graduations there. So that's another way of getting the last decimal place down to a micron, which is a thousandth of a millimeter. That does not mean that this micrometer is capable of measuring to that degree. The pitch of the thread on that micrometer, the tolerance on the pitch of the thread off the factory when this micrometer was made is 1 micron exactly. So you're always going to possibly have a 1 micron or 1/10 of one of those divisions out anyway. So it could be out there and it still would be within tolerance. But normally we can estimate a half down to about 0.025, maybe a quarter of one of those divisions there. We'll get reasonably accurate, provided of course the finish was quite high. It needed to be a ground finish, like a slip gauge here. You could get quite an accurate measurement. There is a slight variation on this though. If you see, I'm going to have another micrometer here. This one here says here, it's a 0 to 25, and the smallest dimension is 0.01. Let's look at another micrometer with a slightly different way of reading it. We'll look at this one here. On the frame, this reads 0 to 25 and 0.001 millimeters, and that is a micron. And what this micrometer here they've done, it's a Mitsubishi Toyo as well, is they've divided up they have a vernier scale around this one here. That's the vernier scale. This is the normal 0.1 we pointed out before. But each one of these little graduations here along the barrel is one, I think the distance is from one to the next is 0.001 less than a millimeter. So by reading across this, if I put that onto a half dimension there, around about there, I'll lock that up. And then sight around this particular barrel here, there's numbers around here. At the 5 line there, you should see that lining up. Now, I'm rushing a little bit here, but that will give you an idea of what the last decimal place is. And because this has a vernier scale on it, the smallest graduation it's capable of measuring is down to 1/1000th of a millimeter, which is what it says on that particular badge there. So that's just a slight variation. To be honest, I actually prefer one of these ones here and actually estimate without the vernier scale a regular micrometer like this. I find this much more, I really don't have much of a problem reading down to 10 graduations. I only really, when you consider the errors that could possibly be there, I believe that probably about 0.25 would be around about the 0.25, sorry, would be around about the precision this micrometer is capable of anyway. And I'm quite capable of estimating whether that's a quarter or a half or a 3/4 division past each graduation there for the 3rd decimal place. And that is micrometers. Never ever wind a micrometer any more than 1 millimeter past its maximum distance. Here it's 25 millimeters. I would never wind that much more than 1 full turn or half a mil past the 25, and never ever wind these out all the way. For some reason or other, the thread goes tight and will stay tight forever. So don't ever wind these past there. If you do need to do some maintenance there, there's a couple of ways of stripping these down without actually removing the thread, but I'll talk about that in another video. And that is micrometers. We'll look at another one here. This is a 25 to 50, and that starts at 25. To zero this, you would need to have a block of 25 millimeters, or usually they come with a test bar. I don't have one for this particular mic, but I do have a slip gauge of 25 anyway. And that will meet up to 50 millimeters, and of course there's 50 to 75 and so on and so forth. I've actually used micrometers up to around about a meter, with different changeable length rods on the end of it, but up to about a meter is there's even bigger ones than that, but they are quite cumbersome things. You need 2 people to use them properly. And that's micrometers. And I'm Mark Wilson, and thanks for watching.